universe evokes inexhaustible astonishment and awe. Further exploration leads to an accumulation of revelations. Although considerable attention is frequently directed towards remote galaxies and black holes, it is critical to bear in mind that astounding revelations can also be discovered in closer proximity. Consider the instance of APOPHIS, an enormous asteroid that astronomers at the Kitt Peak Observatory discovered by accident in June 2004. It had remarkably been unnoticeably drifting through space for an undetermined period of time. With the accumulation of data, scientists gained the ability to approximate its future trajectory. They were taken aback when they learned that APOPHIS had a 2.7% chance of colliding with Earth in April 2029, which happened to coincide with the infamously inauspicious Friday the 13th. As a result, APOPHIS was assigned the classification of one of the most perilous asteroids currently recognized by the human race. Despite subsequent investigations disproving the likelihood of a catastrophic event occurring in 2029, this celestial entity remains an extraordinarily advantageous prospect for humankind. Through the investigation of APOPHIS, we can acquire indispensable knowledge regarding the cosmos and enhance our capacity to safeguard our planet against prospective perils presented by additional asteroids. Prepare to witness APOPHIS 2029 close encounter. Hello everyone, welcome back to Zeey. In this video we will see the APOPHIS trajectory and the exact date it will get close encounter with Earth. Subscribe to our channel and follow us. APOPHIS description. APOPHIS, an exceptionally massive asteroidal body, is estimated to have a diameter of approximately 350 meters, which is comparable to the length of 3 football fields or marginally taller than the Eiffel Tower. Prior radar observations have demonstrated that APOPHIS possesses a discernible morphology reminiscent of a peanut or 2 interconnected lobes. A bilobed morphology is frequently observed on larger near-Earth asteroids, comprising an estimated 1 out of every 6 asteroids. The bilobed morphology of this celestial body is hypothesized to have originated from the collision of 2 distinct progenitor asteroids. By means of a very low impact velocity, these asteroids retain their original spherical configurations, resulting in the formation of the bilobed shape. Nevertheless, bilobed configurations can also result from exceptionally destructive impacts. Throughout the collision, a multitude of fragments are expelled within a sizable curtain. These residual parts have the potential to collide with one another, resulting in the development of bilobed features. The investigation of APOPHIS and its properties is critical due to the valuable insights it offers into the characteristics and behavior of near-Earth asteroids. APOPHIS, which is quite peculiar, not only maintains its orbit but also experiences twisting and rotation. Presently, astronomers are engaged in efforts to gain a more comprehensive understanding of the spin state of an asteroid, which comprises its axis of rotation and rotation rate. With this vital data, they will be able to ascertain the asteroid's orbital inclination with respect to Earth as it nears the gravitational field of our planet in 2029. Significantly approaching Earth in the near future is the enormous mass of this asteroid. The danger. Since quite some time, astronomers have been preoccupied with determining the precise trajectory of APOPHIS and estimating the probability of a forthcoming collision. Upon its initial detection in 2004, astronomers formulated predictions regarding potential impacts in 2029 and 2036. Fortunately, subsequent observations of this near-Earth object, NEO, dispelled these apprehensions. However, until recently the likelihood of an impact in 2068 remained minute. The asteroid passed through Earth at a distance of around 17 million kilometers on March 6, 2021, which is equivalent to 44 times the distance to the Moon. Notwithstanding its considerable separation, astronomers successfully computed the distance and optimized the asteroid's trajectory prior to its forthcoming approach in 2029, which is anticipated to transpire on April 13. APOPHIS's pass within 35,000 kilometers of Earth on Friday, April 13, 2029, will constitute the most critical near encounter. This proximity is considerably closer than the Moon by a factor of 10. Furthermore, the asteroid will be visible to the unaided human eye. Numerous individuals voiced apprehension, might the astronomers have committed even a slight error in judgment, which might have resulted in a potential collision with Earth. Should such circumstances arise, we would be in peril. However, there is no cause for concern, as the calculations of astronomers can be relied upon. In 2029, it will be secure for human beings to inhabit the planet. Prior to the 2029 flyby, it was unknown whether Apophis' orbit would be altered to the extent that a future collision would occur during its voyage around the Sun. The passage of Apophis through a gravitational keyhole has the potential to result in an impact in 2068, albeit with an exceedingly low probability. Thankfully, recent radar observations have substantially diminished the uncertainty surrounding the trajectory of Apophis. Taking into account the orbital effects of the flyby in 2029, the possibility of an impact occurring in 2068 or at any point thereafter has been categorically eliminated. Apophis picture. Additionally, have you ever pondered the visual characteristics of an asteroid as observed through a telescope lens? Permit me to demonstrate a breathtaking image. This image of the perilous asteroid Apophis was captured in Rome, Italy by the Virtual Telescope Project. The date of the photograph is March 2, 2021. The asteroid is depicted in the image as a minute dot, whereas the stars in its vicinity are rendered as trails. This is due to the fact that the telescope tracked the asteroid's path through space. The object's velocity of approximately 2.894 miles per second or 4.658 kilometers per second in relation to Earth is quite intriguing to observe. While the photograph was being taken, Apophis was a remarkable 17 million kilometers from Earth. Consider the perspective of being able to observe an object of such magnitude as the Eiffel Tower from such an immense distance. Nevertheless, images of asteroids were not consistently of this caliber. For example, this is the appearance of Apophis at the time of its initial discovery in 2004. Let us now proceed to the most thrilling portion. You should not fail to attend the extraordinary event that is the advent of Apophis. Permit me to therefore direct your attention to the locations around the world where you can observe this extraordinary phenomenon. Visibility zone. At the outset, Apophis will attain visual discernibility in the nocturnal atmosphere of the Southern Hemisphere, traversing the Earth from the eastern to western coasts of Australia. By the time Apophis passes above Australia, the east coast of the United States will be at approximately mid-morning. Subsequently, the asteroid will pass through the Indian Ocean and, by the afternoon in the eastern United States, will have traversed the equator while continuing its westward trajectory over Africa. Just prior to 6 p.m. Eastern Daylight Time, when Apophis approaches its closest point, it will be situated atop the Atlantic Ocean. Due to its exceedingly high velocity, it will traverse the entirety of the Atlantic Ocean within a single hour. The asteroidal trajectory will have concluded its traversal of the United States by 7 p.m. Eastern Daylight Time. Following the closest approach, Apophis will disappear from view as it enters the daytime sky. Approaching Apophis. The imminent approach of Apophis in 2029 offers an exceptional scientific prospect. By employing optical and radar telescopes, a close examination of the asteroid will be possible, potentially yielding images of surface features measuring a few meters in diameter. This shall yield significant insights regarding the form of Apophis. Furthermore, we possess the benefit of a specialized spacecraft known as OSIRIS-REx, which will approach Apophis in close proximity. A limited number of months ago, OSIRIS-REx accomplished the last objective of this mission through the release of its sample capsule, which contained fragments of the Bennu asteroid. At present, these samples are undergoing analysis in laboratories located on Earth. The results are anticipated to offer unparalleled perspectives on the genesis of the solar system. Notably, the spacecraft changed course just prior to its scheduled delivery by activating its engines, reorienting itself towards Apophis, and subsequently being designated OSIRIS-APEX. OSIRIS-APEX is projected to enter orbit around Apophis in the immediate aftermath of the asteroid nearing Earth. Its objective is to determine how this encounter has affected the orbit, rotation rate, and surface of the asteroid. As stated earlier, APOPHIS will be observed by the spacecraft both prior to and subsequent to its close encounter with Earth. This is critical because specific alterations occur when an asteroid approaches a planet. Initially, it is positioned in an alternative orbit. Subsequently, it may experience material loss, resulting in a modification of its mass. Please allow me to elaborate on these points. In order to ascertain the exact location of an asteroid, observations are required. Telescopes monitor the trajectory of the asteroidal object, while methodologies aid in ascertaining its probable course by utilizing accessible data. Nevertheless, these observations are accompanied by a degree of uncertainty and are not entirely precise. The most accurate estimation of the asteroid's location at a given moment is limited to what astronomers can provide. The actual position may differ from this figure. An increase in the number of observations conducted leads to a reduction in uncertainty, thereby improving the precision of the asteroid's position determination. When an object approaches Earth in close proximity, however, the level of uncertainty increases substantially. This is the result of the Earth's gravitational force, which modifies the orbit of the object, and the Earth's drag, which may induce material loss from the asteroid's surface. Consequently, it is critical that OSIRIS-APEX conducts APOPHIS observations both prior to and subsequent to the approach. By doing so, we can increase our knowledge of the universe and gain a deeper understanding of the effects that Earth has on APOPHIS. Investigating asteroids is critical in the pursuit of understanding the origins of life. It is believed that these celestial entities are remnants remaining from the process of planet formation, and they contain indispensable knowledge regarding the chronology of our solar system. Observing the immense magnitude of the universe is comparable to reflecting in a mirror. As we investigate further, our understanding of our own identity expands. Our unquenchable and extraordinary curiosity drives us into unexplored domains where no one has previously ventured. Truly exciting, isn't it? Alright guys, that is all for this video. Thanks for watching. Do you anticipate witnessing APOPHIS's transit by Earth in 2029? Let us know in the comments below, and don't forget to like, share and subscribe.